Okay, so 21.6 is all about polymers. And polymers are very large molecules. Their molecular weight could be 10,000 grams per mole or even more. And these very large molecules are made up of just repeating single smaller units that we call monomers. So a monomer is one small group of atoms, and when they're stuck together, so you have thousands of different monomers all bound together, then that makes a polymer. And hopefully you see the mono and poly make a lot of sense with that. There are different types of polymers, but we're going to talk about two in particular today. So a condensation polymer is one that is formed through a condensation reaction. That means it can be formed through amide bond formation or through ester formation. The amides we actually covered a little bit when I talked about proteins. And so a protein is a condensation polymer. But you've probably also heard of polyester. So polyester is a polymer that's made by the formation of many ester bonds. So if you look here, what you have as your starting materials when you want to form a polyester is a dicarboxylic acid and a dialcohol. So the carboxylic acid can be as long as you like, and you'll get different properties depending on how long you have the carbon chain between the two carboxylic acids, but at either end it's got carboxylic acid. And then the dialcohol also, it can be as long as you like in between, and then on either end there's an OH group. And so if you were to do a condensation reaction between these two monomers, then you would form a bond between the two of them, an ester bond, but you would also have on the left side a carboxylic acid ready to attach to another alcohol molecule, and on the right side you'd have another alcohol ready to attach to another carboxylic acid. And so you wouldn't just form one ester, but you would form many ester bonds between all of these different monomers, making one big chain. And so that chain would be called a polyester because there's lots of ester bonds being formed. And you see there in this figure that you could sort of draw brackets around the smallest repeating unit, right, showing how it's ready to make one ester bond to the left and a new ester bond to the right, and the ester bond that you just made is smack in the middle. Okay, so this is the smallest repeating unit, and you can put brackets around that and then just put a little n to indicate that the real molecule has some number of these ester units. And n could be very long. It could be, hundreds, or it could be thousands or tens of thousands, depending on the conditions that you run the reaction. So the next type of polymer that we're going to look at is an addition polymer. So addition polymers are always going to be formed from alkenes or alkynes, usually alkenes. And so you'll have monomers that have a double bond, and the mechanism for how these alkenes will polymerize or will bond together, that mechanism is something we won't cover today. It involves radicals, which are molecules that have an unpaired lone electron. But suffice it to say that the electrons which make up the pi bond, the pi component of each of those double bonds, those electrons are going to form new covalent bonds between the carbons, between the monomers. And so, every monomer there, every ethene molecule that we see has 2 electrons in the pi bond that are ready to go form a new sigma bond, a new covalent bond with its neighbor. And so the polymer you see on the right is actually very simple. It just turns into one big long alkane. And again, this alkane could be 10,000 grams per mole. Those are addition polymers. This one's called polyethylene because the monomer is ethylene. And you stick a lot of them together and you get polyethylene. Of course, polyethylene, just like polyester before, is just kind of a descriptive name of a category of polymers. With the polyesters, depending on how long your diacetic acid and your dialcohol chains were, and depending on the conditions that you have when you form the polymer, you'll get different properties. And with the polyethylene as well, depending on what conditions you have when you run it, what's the concentration of the ethylene molecules, what's the concentration of any catalyst you might have, or any what we would call a quencher, a molecule that stops the reaction prematurely. Things like that can control just how big your polymer is. And so polymers have very different properties than the monomers themselves do. You know, the polyester, for example, is made up of alcohols and acetic acids. Well, polyester is not acidic and it's not alcoholic. It's got its own properties, but the monomers do affect the polymer properties. And so it's a very rich field of chemistry to tweak the properties of the monomers, choose monomers that are just slightly different in this way or that way in order to make a polymer with different properties. So there's one, whoops, went too far. Okay, this is a bit of a cluttered slide, sorry, but these are different addition polymers that are around us in the world. Milk jugs, plastic bins, styrofoam, all of these are things that we interact with every day. They're addition polymers that are made from slightly different monomers. The one down there at the bottom, tetrafluoroethylene, is polymerized to make polytetrafluoroethylene, or PTFE. That has a brand name of Teflon, right? So that's a non-stick coating that might be on your cookware or whatever else. And the fact that it's covered in fluorine molecules is what gives it the non-stick properties. It's otherwise kind of identical to polyethylene, which is just trash bags and milk jugs, your sort of common disposable plastics. But the fluorines are different than hydrogens, and so the polyethylene is different than the polytetrafluoroethylene. So the discovery of polymer chemistry started sort of a second mini industrial revolution that is based on the development and the manufacture of new different types of plastics. You can't hardly go anywhere in the world without having a plastic within literally inches of you. You're probably wearing some sort of a plastic, if we count polyester. You're wearing some sort of a polymer somewhere on your body. Almost everything you touch has got some plastic component on it somewhere, and really very much of sort of the industrial side of modern life is saturated with polymer chemistry. So it was really exciting when these things were first discovered. You know, they were almost like miraculous materials that were able to change the world in a lot of ways. So that is polymers, and that actually ends chapter 21. So tomorrow we'll get into chapter 22, talking about inorganic chemistry, coordination chemistry, and we're getting pretty close to the end here.